So, as we discussed, we are going to focus completely on BJT. So, don't worry about MOSFET, FET, IG, FET, whatever FET family devices. We are not going to consider them. We are going to narrow down our study to only BJT. This forms the basis of a three-terminal semiconductor device, right? So, if you understand the functionalities of a BJT, then it is going to be similar because FET is also a three-terminal device and FET and BJT are analogous, right? So you can relate the parameters of BJT and FET and you can make your understanding easy. So as you see, BJT, you know, it's a three-terminal semiconductor device. Yes, as Srinivasa Venkatan told, it is a three-terminal device. So it has three terminals, emitter, base, and collector. Can you recollect and say what is the purpose of emitter, base, and collector? Srinivasa Venkatan can be silent for some time because he has answered more number of questions. I need answers from others. So what is the purpose of emitter, base, and collector in a BJT? Just I'm asking questions for recollecting the concepts, okay? So be free, feel free to answer the questions. You have written the exam also, emitter, base, and collector. What is the significance? Why do we need three layers, emitter, base, and collector in a BJT? Yes, I don't want to pinpoint your names and answers. The moment you answer, your name will be off the list. What is the purpose of emitter? Purpose of emitter? Emitter is going to emit your carriers and collector is going to collect your majority carriers, and base is the region where you have very small recombination happening. I have been telling this example, right? So if you have 100 electrons emitted by emitter region, 95 electrons will cross over the depletion region and go to the collector, which will constitute collector current. The 5 electrons will recombine with holes in the base region, constituting to what is called as the base current. That's how we have the equation emitter current equal to collector current plus base current, right? So BJT is a three-terminal semiconductor device. So the three terminals are emitter, base, and collector, and the operation depends on both majority and minority carrier. So that is the reason why you call it as bipolar. Bipolar means it involves the two charge carriers, that is electrons and holes. Electrons are majority carriers, holes are minority carriers. In a PNP transistor, holes are majority carriers and electrons are minority carriers. So you cannot neglect the effect of minority carriers in BJT because they also contribute to current. So the BJT is called as bipolar because it involves the unity between both majority and minority carriers, and it has two PN junctions. So it is a junction transistor and it's a three-terminal device. So it's a three-terminal, two-junction bipolar device, to be very to make it short and sweet. Okay. So previously, before these diodes and BJTs came into picture, you have what is called as vacuum tubes. You have what is called as the vacuum diode, vacuum triode, vacuum pentode. Those devices are going to operate in a very high voltage, and these are very big in size. All these vacuum tube devices, which were in use before the invention of all the family of semiconductor devices, they were very big in size and they were operating at a very high voltage, say 1000 volt, 2000 volt, which you cannot touch because you will get enormous amount of shock and you will die. So when you operate these vacuum tube devices, you have to be very careful. But when moment these diodes, BJTs, and family of FETs were invented, they were giving the same properties of these vacuum tube devices, but the size is also less, the operating voltage is also less. BJT is going to operate in maximum 12 volt. 12 volt DC is enough to operate a BJT. Whereas in vacuum tubes, you need 200 volt, 300 volt, 1 kilovolt, volt, and where is 1 kilovolt. So these vacuum tube devices were costly and they were very big in size and they were also dangerous to operate. But the semiconductor technology ensured that the diodes, BJT, FET, CMOS, whatever was invented, they were giving the same performance as your vacuum tube devices. Size is also less, cost is also less, operating voltage is also less. So the moment these devices came, all those vacuum tube devices vanished because people started using these devices immediately as soon as they were available in the market. And BJT is used in amplifier. So main application of BJT is amplifier and oscillator circuits. So amplifier is a device which will boost your signal strength. Okay. And oscillator is a device which is going to generate signals and act as a switch in digital circuit. See here, when I'm going to use the device in active region, I'm going to use it as an amplifier. When I'm going to operate the BJT in saturation and cutoff region, I am going to use it as a digital circuit. Because digital circuit means either 0 or 1. 0 means no current. 1 means high current. 0 corresponds to cutoff region. 1 corresponds to saturation region. Okay, so all the regions of BJT is used in electronic circuits. Wherever wherever the application demands, we are using the BJT in that particular region.